Hello again. Now that you've read Chapter 10, Postpress and Finishing, let me review some of what you learned. Postpress and Finishing includes all of the processes that turn sheets of printed material into the books, brochures, and boxes that we use every day. Let's talk about cutting. A machine used for cutting press sheets into individual pages, typically offline, is called a guillotine cutter. In some of the latest applications of job definition format, JDF that is, to be covered later in this book, guillotine cutters can be programmed to know the cutting specification of the next job coming off of a printing press and automatically presetting the cutter to expedite the cutting process. This is what we're seeing in some of the most modern applications of cutting on some of the most modern, technologically advanced printing presses. Folding, on the other hand, except for mailers, posters, and other single-page jobs, printed sheets must be folded into the correct sequential order for reading. Each press sheet is folded to create what we call a signature, a term originally from medieval bookbinding. There are three different kinds of folders used in modern printing. Well, one is not so modern. That would be the bone folder. These folders are simple, shaped pieces of bone or plastic that are passed over the fold to form a sharp crease. Then there are knife folders. Knife folders use a thin blade to force the paper between two counter-rotating rollers. And then you learned about buckle folders. Buckle folders differ from knife folders in that the sheet is made to buckle and pass between two rotating rollers of its own accord. Then there's the matter of assembly in postpress and finishing. The assembly process brings all of the printed and non-printed elements of the final product together prior to binding. Assembly usually includes three steps. It includes gathering, collating, and inserting. Then there are various binding methods. Binding is the process of attaching multiple units of printed material as a single piece, either with a protective and often decorative cover, or with the sheets or signatures alone. The latter is known as self-cover and is typical for brochures and collateral, while the latter is common for books and periodicals as well. In saddle stitching, one or more signatures are fastened along their folded edge with wire, staple-like stitches. The term saddle stitching comes from an open signature's resemblance to an inverted riding saddle. An alternative saddle binding process called Smythe sewing is considered to be the highest quality fastening method used today. The center sewing approach produces a book that will lie almost flat. Adhesive binding, also known as padding, is a simple form of binding that includes detachable sheet notepads and noteback books using a process called perfect binding. Covers. For many binding types, a cover is simply a heavier weight stock intended to protect the contents from ordinary wear and tear. Soft covers for perfect bound books are usually cut flush with the inside pages and attached to the signatures with glue. Although they can also be sewn in place, cover stock is typically coated on only one side to facilitate high quality printing. Book cover art also serves a marketing purpose. to attract potential buyers and help them feel good about the purchase. They can also be embellished with special finishing effects, such as embossing, discussed later in this chapter. Then there are finishing and special effects. There are still many steps to perform before a printed piece is ready for use. These range from the mundane, such as envelope insertion, to the spectacular. The latter include die cutting or laser cutting, embossing, debossing, metal foil stamping, special coatings, raised surface effects, and even insertion of electronic tags or radio frequency identification known as RFID chips. Die cutting is a process where a segment of the printed document is cut into a special shape, such as a circle. Triangles, or any other shape for that matter, can be produced via die cutting. Embossing creates a raised printed image, whereas debossing creates a recessed printed image. Blind embossing or debossing creates a raised or recessed impression without printing, without a printed image. Foil stamping gives a metallic look to the embossed or debossed image. Then there's inline finishing. Historically, many finishing operations were manual, labor-intensive operations, handled within a printing company or by a trade bindery, including basic bindery, such as cutting, perforating, folding, trimming, and stitching. Then there's inserting a single piece or multiple pieces into an envelope or other pre-printed enclosure. Then there's labeling, either by imprinting the original piece or applying an adhesive printed label. Then there's poly bagging, where each piece in a weatherproof, mail-ready enclosure is included. Then there's boxing and palletizing. Boxing and palletizing the printed content of mailing or shipping is an important part of post-press and finishing. Then there are special effects. For high-impact pieces, special effects are the delight of graphic designers and historically a high-cost challenge for print professionals. They're applied at many points in the manufacturing process, both during printing, for example, spot varnish effects, or in post-press. While some finishing effects require costly manual labor, an increasing number are now applicable with digital inline technology. Embossing, which means a raised surface, and debossing, which means a recessed surface, effects are used not only to accentuate type or other visual design elements, but also to give the paper surface an additional texture or dimensional effect. This must be done after printing, which requires a flat surface for optimal reproduction quality. Then there's metallic foils, foil stamping, and laminates are also applied after printing for many of the same reasons. Often, these effects are used in combination, as with paperback book covers featuring titles that are both embossed and varnished. Similarly, greeting cards often feature innovative die cutting and special foils or laminates to accentuate their appeal. Die cutting, embossing, debossing, and foil stamping are becoming increasingly popular due to the availability of automated processes for producing dies. Die cutting has become increasingly used to embellish printed products due to automated electronic processes, including CNC, which means computer numeric control machines. Such machines have allowed fine enhancements to printing and embossing, debossing, 3D die cutting, and for foil stamping, and are increasingly being used for package printing, greeting cards, book covers, enhancements, and for the general range of commercial printing. Programmed CNC machines eliminate the tedious handmade dies traditionally used in the industry and are available from a number of manufacturers. Then there's the digital bindery. With digital printing growing in popularity, many service providers find that they now need to offer a variety of binding and finishing services. Commercial printers, publishers, direct marketers, and service bureaus can offer digital print services, short print runs, delivery on demand, variable, customized, one-to-one content, as well as high-quality color. However, these value-added services mean little if the binding and finishing applied to the printed products are not of sufficiently high quality. The digital bindery. With digital printing's growing popularity, many service providers find they now need to offer a variety of binding and finishing services. Commercial printers, publishers, direct marketers, and service bureaus can offer digital print services, short print runs, delivery on demand, variable, customized, one-to-one content, as well as high-quality color. However, these value-added services mean little if the binding and finishing applied to the printed products are not of sufficiently high quality. So what of the future? What are we facing in the future? Over the past few years, with growing demand for integrated inline or semi-integrated nearline finishing, it became clear that a new open communication standard was needed to allow digital presses and finishing devices to talk to each other. In response to these issues, OEMs of digital presses and Postpress equipment developed the Universal Printer Pre- and Post-Press Processing Interface known as UP3I. Compatible with JDF, it is an attempt to solve problems inherent with digital devices. These include shortening setup and preparation times, enabling remote setup, maximizing the efficiency of any printing or finishing line, facilitating and implementing with job tickets, especially JDF, supporting both continuous form and cut sheet printers, and enhancing job recovery in the case of common mechanical occurrences such as paper jams.